Alright, time for another LeetCode problem. This time, let's do merge sorted array. Okay, number 88, merge sorted array. Easy. 332 upvotes, 45 downvotes. Okay, we are given two integer arrays, numbers 1 and numbers 2, sorted in a non-decreasing order, and two integers m and n, representing the number of elements in numbers 1 and numbers 2 respectively. Merge number 1 and number 2 into a single array sorted in non-decreasing order. The final sorted array should not be returned by the function, but instead be sorted inside the array nums1. To accommodate this, nums1 has a length of m plus n, where the first m elements denote the elements that should be merged, and the last n elements are set to 0 and should be ignored. Numbers 2 also has a length of n. Okay, for example, nums1 is 1, 2, 3, 0, 0, 0, m equals 3. Numbers 2 is 2, 5, 6, n equals 3. The output should be 1, 2, 2, 3, 5, 6. Okay. Example 2, numbers 1 equals 1, numbers 2 is null, n equals 0. The output should be 1. The arrays we're merging are 1 and empty. The result of the merge is 1. Example 2, numbers 1 is 0, m equals 0, numbers 2 is 1, n is 1. The arrays we're merging are empty and 1. The result of the merge is 1. Note that because m equals 0, there are no elements in numbers 1. The 0 is only there to ensure the merge result can fit in nums1. Okay, so let's get back to main and our coder pad. Declare our function merge, which takes the arguments nums1 of type int array, m of type int, nums2 of type int array, and n of type int. And it returns unit. We don't care about the return value, we just care about the contents of nums1. We're storing everything inside the array nums1. Okay, our constraints. We know that nums1 length equals m plus n, nums2 length equals n, 0 is less than or equal to m, n is less than or equal to 200. N is less than or equal to m plus which is less than or equal to 200, and numbers are between 10 to the minus 9 and 10 to the positive 9, so we do not overflow out of our integer 32. Okay, cool. So let's see what we have here. Let's start thinking about this. So we have our numbers. Let's get a blue palette to denote what we're starting with. 1, 2, 3, 0, 0, 0. And we have 2, 5, and 6. Okay, clarifying question. Can I use built-in sort functions? If so, then all I would do is I would assign these numbers to the elements of numbers 2 to the final elements of numbers 1, knowing the start index of doing so, that we're able to do so. Add them all, and then use a built-in sort function. That would give us a solution in n log n time, and probably, I can't remember what the best sort spaces are, n anyway. Something like that. But I got a feeling we're not allowed to use built-in sort. Okay, the follow-up is, can I come up with an algorithm that runs in OM plus M time? I'm not going to try to do that yet. So another solution we could do is we could make an empty array. No, we're checking numbers 1. We can't return a new array, unfortunately. That would be another nice solution. Well, we could create a temporary array and then move the contents of the temporary array into one. I like that solution a lot. Why don't we do that? So we will contain an we will instantiate an empty array. We'll go with red for the first step of length m plus n, and it will look like this. Val temp equals int array of size 6, not 6. What am I doing? M plus M. And we have to do a pointer at the beginning of both of our arrays. We know numbers 1 is longer. And we know numbers 2 cannot be longer than numbers 1. So let's assign our 2 pointers. Variable I equals 0 and variable j equals 0. Here are our 2 pointers, I and j. And we'll do a while loop while I is less than m. I is the index. I is a 0 index, and then m is a 1 index of size. First m elements, yep, m is 1 index, so yes, we are using less than, not less than or equal to. J is less than n, except not and. We want to do or to make sure they're both empty. Then we'll say if I is greater than or equal to m, no, hold on. Okay, we're getting a little bit hung up on these edge conditions. If let's do var k equals 0, which is going to be the pointer which points to this guy. If I is greater than or equal to m, then temp k equals nums 2j. If j is greater than or equal to n, temp k equals numbers 1 I. Then we'll do I++, j++, k++. We know these never can both be true. And if neither of them are true, then we'll say temp k equals math max Now let's do this. Let's do it like this. K will always increment. If nums 1 I is less than nums 2j, we want to take it because we are sorting ascending, so we want to take the smallest numbers first. If numbers 1i is less than numbers 2j, we take it. We take numbers 1, temp k equals numbers 1i, and then we increment I, else temp k equals numbers 2j, and then we increment j. Okay. I believe at this point our temporary array is going to be exactly what we want. So at the end, for L in 0 until num1 size until, not including. The range 0 until num1 size. We want num1 L to be assigned to the value of temp L. Okay, cool. Now I've done it in 2 passes. With 3 pointers. And we have taken an additional n memory. But it doesn't say we can't do any of that. So let's debug our solution and make sure it looks good. So I, j, and k all start at 0, while I is less than m, which is 3, and j, well, I is less than m, which is 3, or j is less than n, which is also 3. I is not greater than m, j is not greater than n. Then, therefore, if numbers I is less than numbers 2j, temp k, numbers I is indeed less than numbers 2j, temp k is equal to number 1I. We'll use green for our third one. 1, and then we increment I, skip the else loop, return out of the encapsulating else loop, and increment k. Okay. The while loop will continue. While I is less than m is 3, I is now 1, and, or, okay, we can pass this already, so we're on to the next one. If I is greater than or equal to m, it is not. If j is greater than or equal to n, it is not. Else, if numbers 1I is less than numbers 2j, it is not. So we skip this. Else, temp k, which is now 1, is now equal to numbers 2j, which is 1, which is 0. So we delete this, replace it with a 2, and we increment j. Now we can exit the else loop, the encapsulating else loop, and increment k. Okay. So then we go through our while loop again. If I is less than m, I is now 1, m is 3. We're good. If I is greater than m, it is not. Else, if j is greater than or equal to n, it is not. Else, if numbers 1I is less than numbers 2j, we take it, and we set temp k to 2. And we increment I, and then we increment j. Now, we increment I, then we increment k, excuse me. We go to the next loop in the while loop. I is less than m, so we're good there. I is now 2, it's less than 3. I is, if I is greater than or equal to m, it is not. If j is greater than or equal to n, it is not. Else, if numbers I is less than numbers 1I is less than numbers 2j, it is. So then we're going to take 3. We're going to take 3, store it at temp k, and increment I. And then increment k. Now this while loop is done. Okay, now we see if I is less than m, it is no longer less than m. Is j less than n? Yes, it is. If I is greater than or equal to m, temp k equals number 2j. So temp k becomes 5. We made a bug. We need to increment j here and increment I here. So then j should be incremented. So this is take k, and this is take I. And then we increment k. Now we do the while loop again. If I is less than m, which it is not less than m, I is now 3, m is 3, or j is less than n, j is now 2, n is 3, so yes, we continue the while loop. If I is greater than or equal to m, which it is, we take j. Temp k equals numbers 2j, and then we increment j, which is now out of bounds. Increment k, which is now out of bounds, and if I is less than m, which it is not, and j is less than n, or j is less than n, which it is not, we don't continue this while loop. Okay, cool. Now we have our sorted array. For I in 0 until num's 1 size, for L in 0 until num's 1 size, 1 size is 6, so we're going from indices 0 to 5. We're going to say numbers 1 equals temp 1, and then we'll return. So this looks like good code. Let's check and see if we have any. There's no issues with null. I think we can just basically just submit this. This looks good. And the drawing was handy. I really like that. What? An error occurred. Oh, I mistyped. See if we can find num1. Do we have a num2? Okay, so we made another mistake. Typed num1 instead of nums1. So since we're using CoderPad, we ought to make use of the AutoComplete. Let's run our example test cases. They should be good. You can submit it. Okay, we got a very fast solution on our first try with just a couple of syntax errors which can be corrected by using autocorrect. That's not too bad. We're getting better at this. That's an encouraging sign. That's 3 LeetCode problems done. We're very close to okay, merge and sort. That's the first approach that we came up with. We'll take a look at 3 pointers in a minute. Oh, that's brilliant. 3 pointers start from the end. Okay, that's the correct solution. Oh, cool. I understand how that works. That's smart. That's tricky. I might try doing that myself after this, but I don't know. I need to get one more LeetCode problem done today. I might do it. We'll see. But for now, I'm going to end this stream. Oh, we still need to figure out how to do test cases. But, yeah, we'll see how it goes. Now a1 equals of type int array equals int array of 1, 2, 3, 0, 0, 0. Now a2 int array of 4, 5, 6. A1, 6, A2, 3. If merge is not equal to an array of Let's see what happens before we run this. Okay, cool. Hey, we got a test case working too. Awesome. Okay, awesome, 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 awesome. Cool. Alright, let's end the stream. I still don't know if I can do equals on this node though. Alright, that's good enough for now.